Hey, what's up, guys? So today we're going to look at scalars and vectors, and these are two different types of quantities, and they're really important. So the first one, scalars, they are quantities with magnitude only, and there's a few that typically come up on the course, and that's distance. We also have speed, and we also have mass. Those are three scalar quantities, and we just represent them with a number. So you might say 5 meters, you might say a speed of 23 meters per second, and you might say a mass of 70 kilograms. We never give a direction with any of those. Vectors, on the other hand, are quantities with magnitude and direction. Instead of distance, we have displacement, and we'll look at the difference between those two in a minute. Instead of speed, we have velocity. Instead of mass, we have the effect of gravity upon that mass, which is what we call weight. And weight is a force, and forces are also vectors. Two other important vectors to know about are acceleration and finally momentum. These are the vectors that we're going to use on the course mainly. So just to recap, scalars are quantities with magnitude only, and we just use a number, whereas vectors have a magnitude and a direction. What's important about vectors is that we often represent them as arrows. The size of the arrow represents the magnitude, and the direction of the arrow shows the direction of the vector. Right, we talked about distance and displacement. So we're going to just use a couple of diagrams to explain the difference between them. So on the diagram on the left, we've got a little spider. And this spider walks this black path, and it's wiggling in and out. The black line represents the distance that the spider has traveled. And that distance is a scalar. And let's say it walked 75 centimeters. There's its distance. It's a scalar quantity. The red line going from A to B is the shortest distance between those 2 points. And that's known as the displacement. And its displacement, you can see, is a lot less. So its displacement might only be 30 centimeters, and it's got a direction as shown by this arrow here. So distance is a scalar, displacement is a vector quantity. Right, on the diagram on the right, we've got a student starting at position A, and they're going to walk around this classroom, and you've got the dimensions there as shown. So if that student walks from A to B, they've walked a distance of 4 meters. The displacement in this case is actually exactly the same. It's 4 meters because the shortest distance between A and B is 4 meters. Now let's have a look what happens if they walk from A to C. So they walk 4 meters along here, then they walk 3 meters down here. So they've walked a total distance of 7 meters. Their displacement, though, is the shortest distance between A and C, and that's given by this diagonal line here. Using a bit of simple Pythagoras, you could work that out to be 5 meters. You'll notice that the displacement is often less than the distance, unless they've walked in a straight line. If the student carries on walking around to position D, their total distance now is going to be 4 plus 3 plus 4, which is 11 meters. But the displacement is now given by this vector here from A to D, and that's simply 4 meters. If we now look at going all the way around the classroom and ending back up at position A, the student has walked 4 plus 3, which is 7 meters, plus 4, which is 11, plus another 4, which is 15 meters. But their displacement now, and this is really important, is 0 meters. They're back to where they started. So the shortest distance between A and A is 0 meters. It's really important to distinguish between distance and displacement. So in summary, distance is a scalar, and it's the total path that you followed, whereas displacement is a vector, and it's the shortest distance between 2 points. Two other quantities, one's a scalar, one's a vector, is speed and velocity. And the definitions are key to understanding their difference. First of all, speed is the rate of change of distance. So we use speed is distance divided by time. Velocity, however, is a vector quantity. And the definition is velocity is the rate of change of displacement. What's slightly confusing here is the symbols that we use. We use V for velocity, S for displacement, and T for time. It's a bit confusing because we also use S for speed. Right, so let's just have a look at this picture here at the left. And these are two cars. I'm a physicist, so I don't spend too much time drawing really accurate pictures. And I can say that they've both got a speed of, let's say, 20 meters per second. So they both have exactly the same speed. However, they're moving in opposite directions. Car 1 is moving to the right, car 2 is moving to the left. Therefore, we can say that if we take to the right as positive, we can say that car 1 has a velocity of 20 meters per second. It's positive, it's moving to the right. Whereas car 2 has a negative velocity, it's moving in the opposite direction. This is really important when we get onto topics such as momentum when we look at collisions, and it's a mistake that students make. The direction is important because speed is a scalar and velocity is a vector. Finally, just a final point to show the difference between speed and velocity. Imagine we've got a plane which is starting at this point here where I've put a blue dot, and this plane flies 400 kilometers due north, then it flies 300 kilometers due east, and let's say that takes a time of 2 hours. So the distance traveled is actually 700 kilometers, but the displacement, I'm using the letter S here for displacement, not speed. Using a bit of Pythagoras, we could work that out to be 500 kilometers, and that's shown with the red line. So if we were to calculate the speed is the distance divided by time, which is 700 divided by 2. So that would be 350 kilometers per hour. But the velocity is the displacement divided by the time. And that is 500 divided by 2, which is simply 250 kilometers per hour. You can see because distance and displacement are different, that creates a different speed and velocity. Right, it's really important just to go back to what the definition of scalars and vectors are. Scalars are quantities with magnitude only, whereas velocities are quantities with magnitude and direction. Thanks for listening. See you all soon.